Okay, so this last video is focused on using this feature to check our ability to deal with random variables, and that's binomial geometric. And I thought the best way to do that was just to share some examples and see what we come up with. Okay, so here's the QR code, there's the link, and this is my phone, and I just want to show you how it works because it's a little funky. I have to admit, I made it. I'm no professional programmer. So we've got a question, I've got an answer to it, and the answer shows up with a little asterisk next to it. There's all kinds of different answers, but that's the one that goes with this particular question. And then you can go over to Get New Question, and a little bit cumbersome, I'm not going to win any programming awards, but you do a little down arrow, you click on the Get New Question, click on the down arrow and choose Me, and then there's a little check mark up here, boom, and it gets a new question. So I go back to the question tab, and it says, according to the Farmer's Almanac, the probability of coaches' reaction levels after a concussion that shows no concern is 0.57. After a concussion, okay, shows probability of the coach's reaction where they show no concern is 0.57, so 57% chance it can be like, yeah, whatever, get back in the game. What's probably the first coach's reaction level you observe will be a no concerned coach's reaction level. Sorry, that's a really weird question. All right, but I will tell you this, if it's 0.57 chance that they're going to show no concern, the first coach that you observe having a no reaction is 0.57. That's just what I call a first trial geometric. It always matches the probability. So let's just go through a few. I'm going to click on the little tab for Get Me a New Question. Click on that, grab that, and then see the little check mark up there and click that. Sorry, it's a little cumbersome. Go back to the question. Quillen was told her coach's reaction level was unusual in terms of concernedness. It looks like her coach's reaction level is a 4 on a scale of 1 to 10. Past data indicate that the data is normally distributed. Ooh, this can be a normal distribution kind of problem. So it's normally distributed with a mean of 4.5 and standard deviation of 1.5. What's the probability that a randomly selected coach's reaction level is less extreme than her coach's? Okay, so I'm going to go to second distribution, normal CDF, and I'm going to say normally show the standard deviation, and that person's reaction level was a 4, and we're saying less extreme than that. So I'm going to say negative infinity to 4 when the standard deviation, the mean was 4.5 and the standard deviation was 1.5. So this is a normal distribution kind of problem. So 0.369 blah blah blah, 0.369 blah blah blah. I go to my answers. I should find this one under, see the normal distribution box versus a geometric versus a binomial distribution. So this app, so to speak, is meant to give you some practice on these things. Okay, let's try a few more so we can get a binomial. All right, so let's go Get New Problem. I'm going to click on that, click on the little plus, go over to the question. Looks like, so we've got a mean and a standard deviation, so I don't want that one. That's just normal distribution. You'll see that the asterisk is down there. I could check those and make sure I'm good with those, but I really kind of wanted a binomial. So Get New Question, the little down arrow, click on that, and pop over back to the question. Nice. According to conventional wisdom, the probability of coaches' reaction levels after concussion that shows no concern is 0.75. If 8 coaches' reaction levels are randomly chosen, so we have a set number that are chosen, 8 of them, what's probably that no less than 7, no less than 7, so that would be 7, at least 7, or even 8. Okay, so of the 8, showing no concern is 0.75. What's probably that no less than 7 reaction level shows no concern? Okay, so this one is going to be a binomial, which is kind of what I was interested in, and I want to show you under second distribution. I've got way down at the bottom, I got normal PDF. Normal PDF will show like what's probably that exactly 7. Well, it said no less than 7, so that would be 7 or 8. So this is kind of confusing. I can do binomial PDF with 8 trials, with a 0.75 success, and I'm looking for 7 of them, Okay, I can do that, and I can pop that back up, but I also have to include the 8, because it said no less than 7, which is 7 or 8, and I could add those two together. So I'm going to go that answer to the previous, answer for the last one, plus the 0.26696777734, and there's my answer. But I want to show you a different way to do it. I'm going to go to second distribution. I'm going to do PDF, not PDF, I just did that one, sorry. Second distribution, normal binomial CDF. I got 8 trials, probability of success is 0.75, and I'm going to put in a 6 here, and that's going to give me the cumulative density function from 0 of them being showing no concern up to 1, 2, 3, 4, 5, all the way through 6. Give me that value, and then do the 1 minus of that to get the complement of that to get that 0.367 that we had earlier. And that should be the answer. So I go over to answers, and you see that, yes, in fact, it is the, well, there's the asterisk and the 0.367. So see if we can get a geometric one. Choose new question, hit the little check mark, go over to the question tab. Normally distributed, this is going to be one of those normal distribution ones. So this just gives you some practice on it. I'm going to go over here, pop in another one, see if I can get a geometric one. Yeah, it's going to be another binomial instead of geometric. And the reason I know it's binomial is because 6 are chosen. You know, so according to my database of incorrect statistics, the probability of headaches after concussion that are intense is this. So I'm going to do the work, and then I'm going to go check the answer. It's going to be under the binomial. This is not a bad way even just to check. Forget the numbers for a minute. Just are you recognizing when it's geometric, when it's binomial, when it's a normal distribution? It might be a good way to do it. So have fun with that, and refer to the learning cards on geometric versus binomial when you need to, just to see if you're getting them right. Thank you.